I welcome all the students to a very important concept of kinematics of rigid bodies in 3 dimensions, and that is the gyroscopic effect of an aircraft. Students often encounter the problem of not understanding properly the gyroscopic effect in an aircraft, and we often see that the students do fiddle with the concept if the propeller is rotating clockwise and the plane takes a right hand turn, whether the nose will be down or nose will go up. The motivation behind this concept is not clearing the doubts of students only, but also to make students understand with the help of equations of kinematics why there is gyroscopic effect in an aircraft. What I mean to say is, with the help of problem 20.1, with the help of the problem 20.1, I will explain what do we mean by the gyroscopic effect in an aircraft. The question says that the propeller of an airplane is rotating at a constant angular velocity, having magnitude omega x, and it's rotating along x-axis. And the plane is undergoing a turn at a constant rate, omega t. Determine the angular acceleration of the propeller if, part A, the turn is horizontal, that is, the turn is in such a way that the angular velocity of the aircraft is omega t along z-axis. And in part B, we have to, if the turn is vertically down, if the aircraft makes a turn in such a way that it keeps its nose in a downward direction, in both the cases, in part 1 and part 2, we have to find the angular acceleration of the propeller with respect to the ground. So how do we approach this question? So we have propeller, and if we look at the sense of rotation of the propeller from the front view, the sense of rotation is anti-clockwise. So we will write down what we have in the information that has been provided to us. So as far as the propeller is concerned, propeller is a rigid body whose motion we have to understand from the ground frame of reference. So we are given angular velocity of the propeller with respect to the aircraft is given to us, and angular velocity of the propeller with respect to the aircraft is given to us as its magnitude is omega x I cap. We are also given the angular velocity of aircraft with respect to the ground is equal to, in case 1, I will take the case 1, it's equal to omega t, it's equal to omega t k cap. It's the angular velocity of the aircraft with respect to the ground. So what we have to find, we have to calculate the angular acceleration of the propeller with respect to the ground. This term we have to calculate. Okay, so the question that is in front of us is that an aircraft is, we have an aircraft. This aircraft is translating along x-axis. Okay, and as far as the blades of the aircraft are concerned, the blades of the aircraft have a sense of rotation anti-clockwise. The sense of rotation of the aircraft is anti-clockwise. Aircraft is rotating anti-clockwise, and in part A, the aircraft is making a horizontal turn. Okay, it's making a horizontal turn. That is, this aircraft is now tending to rotate horizontally. Either if the aircraft is trying to rotate horizontally, the sense of rotation, maybe the sense of taking the turn, maybe maybe the left hand turn, or the aircraft may take a right hand turn like this. Okay, since we are given that its angular velocity is omega t k cap, so if we curl our fingers, its magnitude is omega t and it's along positive z axis. So it means if we have to curl our fingers in such a way that the thumb goes along the z direction. That means that this aircraft is taking a turn. The aircraft is taking a left hand turn. This is the sense of rotation of the aircraft. It's moving along the left hand side. So now what we have to calculate, we have to calculate in this. So the aircraft is initially translating along x-axis. The propeller of the aircraft is having anti-clockwise sense of rotation. The angular velocity of the propeller with respect to the aircraft is given to us. And this aircraft takes a left hand turn such that its angular velocity is omega t. k cap. We have to calculate the angular acceleration of the propeller with respect to the ground. We know from the kinematic equations that angular acceleration of the propeller with respect to the ground is equal to the angular acceleration of the propeller with respect to the aircraft frame of reference plus angular acceleration of the aircraft with respect to the ground frame of reference plus the cross product of the velocity of aircraft, angular velocity of the aircraft with respect to the ground, its cross product with angular velocity of the propeller with respect to the aircraft, this term. Therefore, from this equation, we can have, as far as the angular acceleration of propeller with respect to aircraft is concerned, it says that the speed is constant. That is, angular velocity of the propeller with respect to the aircraft is constant. Therefore, angular acceleration of the propeller with respect to the aircraft will be equal, this will be equal to 0. It also says that the aircraft is making a constant turn. It's making a turn at a constant rate omega t. It means that the angular velocity of aircraft with respect to the ground is constant. Therefore, this term is also equal to 0. So we are left with two terms: angular velocity of aircraft with respect to the ground, that is given as omega t k cap, and its cross product with the angular velocity of propeller with respect to the aircraft, that's equal to omega x I cap. Okay. Therefore, we can say that angular velocity of the propeller with respect to the ground frame of reference is equal to omega x, omega subscript x multiplied by omega t. And we have k cross I, and k cross I is equal to j cap. K cross I is equal to j cap. So this is very, very important expression we are getting. So from the expression we are obtaining, that the angular velocity, so we are attaining that angular acceleration of the propeller with respect to the ground is along j-axis, is along y-axis. So angular acceleration is along y-axis. Okay, so if the angular acceleration is along y-axis, if we will keep our thumb in the direction of this, in the direction of the arrow along y-axis, then essentially our fingers will curl in the anti-clockwise direction. So what does it mean? It means the aircraft whose propeller was rotating in a sense of anti-clockwise with omega x angular velocity, and the aircraft is taking a left-hand turn with an angular velocity omega t, then the propeller of the aircraft will attain an angular acceleration equal to omega t multiplied by omega x. This angular acceleration will be along y-axis, so sense of rotation will be anti-clockwise. What does that mean? That means this entire aircraft will tend to rotate. This entire aircraft will tend to rotate in the anti-clockwise direction. So the nose of the aircraft will pitch down. The nose of the aircraft will go down. This is called the gyroscopic effect. This is the gyroscopic effect of the aircraft. Okay. So what does it say? It says that. So what does it mean? It means that the aircraft propeller rotating anti-clockwise in a sense of anti-clockwise rotation tends to take a left-hand turn. The nose of the aircraft goes down. Now let's suppose the aircraft, in spite of taking the instead of taking the left-hand turn, now let's suppose the aircraft takes a right-hand turn. Okay, if the aircraft makes a right-hand turn, okay, with the same angular velocity magnitude omega t, if you curl your fingers in the direction of this arrow, then the thumb will essentially go downwards. So it means the angular velocity is omega t k cap. The angular velocity of the aircraft with respect to the ground, angular velocity of the aircraft with respect to the ground frame of reference now becomes equal to minus omega t k cap, because the sense of rotation is in such a way that the thumb is going downwards. Therefore, it will be minus omega t k cap. Okay. Again, let's talk about the angular acceleration of the propeller with respect to the ground. Okay. Expression for angular acceleration of the propeller with respect to ground will become angular acceleration of the propeller with respect to aircraft plus angular acceleration of the aircraft with respect to the ground plus angular velocity of aircraft with respect to ground cross product with angular velocity of propeller with respect to aircraft. Okay, this is the expression. Again, angular velocity of the propeller with respect to aircraft is zero. Therefore, this expression is also equal to zero because this is a derivative of angular velocity. This expression is also equal to zero. So we are left with angular velocity of aircraft with respect to the ground. Angular velocity of aircraft with respect to the ground is minus omega t k cap. And we have to take its cross product with angular velocity of the propeller with respect to the aircraft, that is equal to omega x I cap, which becomes equal to omega t multiplied by omega x, and we have this k cross I. If you look at the k cross I, that is equal to j, but and this will be minus. Okay, so k cross I is equal to j. So the angular acceleration, so the expression is angular acceleration of the propeller with respect to the ground frame of reference becomes equal to minus omega t omega x j cap. Now let's see what this equation means. It means that the blades of the aircraft, the propeller was rotating in the sense of anti-clockwise, and the aircraft is now taking a right hand turn. So the angular acceleration the aircraft attains is along negative y-axis. That is the angular acceleration vector. If we try to draw the angular acceleration vector, the angular acceleration vector will be along the y-axis. So now if we put our thumb in this direction, if we keep our thumb in this direction, then essentially our fingers will curl in the clockwise sense of rotation. What does that mean? That means the entire aircraft, the tail of the aircraft will go down, the nose of the aircraft tends to go up. Okay, so look, as the aircraft is taking a left hand turn, the nose of the aircraft is going down, and as the aircraft is taking a right hand turn, the nose of the aircraft goes up. But it all depends upon the sense of rotation of the propeller. If the propeller, in our case, the propeller was rotating anti-clockwise. Now, if the propeller is rotating clockwise, and the aircraft happens to take the left-hand turn or the right-hand turn, I think the students can now, at least with the help of the kinematic equations, easily uh, can easily declare and decide whether the nose will go up or the nose will go down. The reason for nose going up or nose going down is the gyroscopic effect, which is simply obtained as the product of the angular velocities, angular velocity of the propeller with respect to the aircraft and the angular velocity of the aircraft with respect to the ground. So these things are to be taken into consideration when we are talking about the design of the aircrafts, the gyroscopic effects, the gyroscopic effect, which is very, very important. Now, if you talk about the part B of the aircraft says, part B of the problem says, the turn is vertically down. Okay, again we write angular acceleration in for part B. The expression will be angular velocity of the angular acceleration of the propeller with respect to the ground will be equal to angular acceleration of the propeller with respect to the aircraft plus angular acceleration of the aircraft with respect to the ground plus the cross product angular velocity of the aircraft with respect to the ground and its cross product with angular velocity of the propeller with respect to the aircraft. Okay, this expression. Again, this is equal to zero, this is equal to zero because the angular velocity of propeller with respect to aircraft is constant and angular velocity of aircraft with respect to ground is constant. Therefore, their derivatives will be equal to zero. What is angular velocity of aircraft with respect to the ground? That is omega t j cap in the second problem. In the second problem, in this problem, it is omega t j cap here. Okay, it is here omega t j cap. So we're writing this as omega t j cap. Cross product with angular velocity of propeller with respect to the aircraft, that is omega x I cap. So that will be omega t multiplied by omega x. And as far as j cross I is concerned, that's equal to minus k cap. So what does this mean? This means the angular acceleration is along the negative z axis. Angular acceleration is along the z axis. Okay, if we put our thumb in the downward direction, then our fingers curl in this direction. Okay, on this plane, it means the aircraft. So aircraft was initially moving along x-axis. As the aircraft is now tending to move downwards, what will happen? It will not only move downwards, but it will it will rotate. The entire aircraft will undergo the rotation about the z axis. Okay, so this is all about the gyroscopic effect. So the student should be in a position to decide whether the nose will go up or the nose will go down. But the way of doing it is not simply making the guesses by intuitions, no, but by solving the kinematic equations. Thank you very much.